We're going to look at a few definitions in lesson 38. A few more referring to centers and triangles. The first one we're going to look at is the incenter. What the incenter is the point of concurrency when all three angles of a triangle are bisected. So this angle is bisected, or bisected means it divides it in two evenly, and it comes to the other side. This angle is bisected, and this angle is bisected. The point where all three of these lines meet in the middle is known as the incenter. Another definition is the circumcenter. The circumcenter is the point of concurrency if perpendicular bisectors are drawn for every side of the triangle. So right here we have a perpendicular bisector. It divides this side in two and is also perpendicular. We have a perpendicular bisector here, divides this side in two evenly, and is a right angle, and same can be said here. Divides it evenly with a perpendicular bisector. The point where they meet is the circumcenter. Now there are tougher coordinate grid problems that we'll probably do in class together that deal with the circumcenter. I'm not going to do those on the board in this lesson, but we're probably going to do those together just to maybe help you understand those. But they are also not a concept that we will do very often, and it's not super needed. So I'm going to skip on that right now. One more definition. If you have a polygon inside of a circle, and you'll use this more in Algebra 2 as well, this is known as an inscribed polygon. Doesn't matter what it is. It could be a quadrilateral, triangle, pentagon, doesn't matter. But if it's inside the circle, it's known as an inscribed polygon. The circle is now called the circumscribed circle. The circumcenter actually lies at the center of the circle that contains the three vertices of the triangle, but that isn't as important as just knowing that it is a circumscribed circle. And then we're going to look at one theorem and actually use some algebra here. Theorem 38.1 is the triangle angle bisector theorem. And what that looks like is, say you have triangle NMP, and we have this line that cuts through the triangle and bisects angle M. Well, what we can say is we have now created a proportion. And they're proportional. So we would say PM over PO, PM over PO is equal to NM over NO. We do not know that the sides are congruent, we simply know that they are proportional. For example, in example 2, it says use the diagram to find BC. And it gives us AB is 20, DA is 15, and CD is 8. It wants us to find BC. Notice these aren't congruent. Sometimes people think because of the angle bisector that the sides should be congruent. That's not necessarily true. So we create our proportion. We did long side over short side, the line that was bisected, 15 over 8 equals long side, 20 over short side, in this case BC. And now we've created a proportion that we can solve. So we cross multiply. 8 times 20 is 160, and that equals 15 BC. Divide it by 15, get BC by itself. And 160 divided by 15 equals 10.6 repeating. So they gave us a nice fine number there, 10.6 repeating. And that is how you do the triangle angle bisector theorem. But that is the end of lesson 38. That's all we're going to cover.